Welcome to the volatile solids reduction or destruction, depending on how it's pitched to you, math problem. This is a math problem that is directly related to the anaerobic digester part 1 video I put out last week. I will link to that at the end of this video. You'll see it pop up on your screen. Go check it out for more conceptual exam preparation. But this is the math problem that's mostly you're going to see on your entry-level exams, and it's finding out the percent of volatile solids reduced or destroyed in a digester, okay? And before I jump into the math problem, I do want to tell the intermediate and advanced folks and the beginner folks that are learning this why it's important, what you're going to run into on your later exams, okay? So once you figure out this number, entry-level folks, the intermediate version of this problem is to figure out the pounds of volatile solids destroyed when given percent total solids. I'm going to do that math problem at a later time. It's just a pounds formula. And then you incorporate the percentage reduced and you can figure that out. I'm not doing that right now. This is just volatile solids reduction. You can expect to see this. You might see this on a grade 2, grade 3, you might see this on a grade 2. I would be surprised, but maybe. If you've seen it on your grade 2, let us know so we know to put this in the right playlist, put that one in the right playlist. By the way, grades 1 and 2 in California would be like a class C. Grade 3 is going to be your B's, and your 4s and 5s are going to be your A's. And then every state's kind of different, so it's kind of hard for me to tell you what exactly is going to be on which one, but just know this is beginner, this is intermediate, and this is advanced. Advanced is taking that intermediate problem, pounds of volatile solids destroyed, and finding the cubic feet of digester gas produced per pound of volatile solids destroyed. So you need to know that to know that, and you need to know that to know that. Okay, and they may even take this a step further, and after you figure out your cubic feet of digester gas produced, they might give you, make you find your BTUs of energy created per cubic foot. That's actually not very hard. It's just one more step. And British thermal units, by the way, is what a BTU is, in case you weren't aware. You also need to know intermediate pounds of volatile solids destroyed to figure out organic loading to a digester, which is pounds of volatile solids per day per cubic foot. They may give you BOD. It is a test. They're not going to just give you all the little, the easy numbers. And you need to be able to know that your organic loading to a digester is volatile solids per day per cubic foot, not BOD. Okay? And I think I saw that on my 4. I can't remember, but just once you get to the 3 level, the intermediate level, be ready to do that because you just never know when you're going to see some of this stuff. Okay? So let's work this math problem out real quick. And by the way, if you're getting anything out of this, please like, subscribe, pass this to your friends. Let's help folks get certified. So this is a percent minus a percent situation, okay? We got a percentage going in and we got a percentage coming out. So this is not a percent efficiency math problem. You can't do that. It does not work here. That math problem does not work here. This is a totally different equation. So what it is, you convert these to decimal places. So 68% would be 0.68, okay? You do your percentage in minus out over divided by in minus in times out. Well, you notice in times out right here is in parentheses. You got to do this first. If you remember for order of operations from math class, parentheses comes first. Parentheses, exponents, multiplication, division, addition, subtraction, okay? Now, you'll see I did this and this on this step, and I'll explain why in a second. So we have 0.68 minus 0.52, so 68% minus 52% divided by 0.68 minus 0.68 times 0.52. Again, do this first, because if you do it like this, left to right, it'll screw this whole equation up. You got to do the parentheses first. In case you didn't hear me say it, do the parentheses first. Sorry. So that's 0.35, 0.68 times 0.52, plug in your calculator, 0.35. And 0.68 minus 0.52 is 0.16. I went ahead and just did this in one step because these are not related to each other, okay? And I'm comfortable enough with my math that I know when the order of operations will screw me up and when it won't. Okay, so the next thing you do is subtract 0.68 minus 0.35, and that gives you 0.33. 0.16 divided by 0.33 times 100 is 48%, or it may be 48.4%. It just depends on how they want it expressed. And by the way, if you get 68.2%, you need to put 0.682 in here because, I mean, that could be several percentages difference if that's a 8 and not a 6. You know, so if they give you a 2 and a 9, you need to be ready to you know, if this is 52.9% and 68.2%, you use that third decimal place in here, okay? And pay attention to the units they want, because I wrote 48%, but if they wanted 48.4% or 48.5%, I would have used that third number in my answer, because my answer was 0.4848, I believe. I'm doing that from memory. And so I just decided to write 48%. It's not helpful to people watching on a camera. 0.4848, okay? I would have rounded this up to a 5, because that's an 8, and I would have probably written 48.5%. It just depends on what they're asking you for. But, you know, that's the math problem. It's very, very simple. In minus out divided by in minus in times out. Do the parentheses first. That screws a lot of people up. That's why I keep saying it. So anyway, I hope this helped. Please ask if you have any questions. If I move too fast through this, you can always slow my your controls down and make me go slower. Or you can ask a question in the comments below. If you ran into a different variation of this math problem on your exam, please put it in the comments below so we can help people get prepared for their tests. If you have a math problem you want worked out, please ask. I've had all sorts of people find me on LinkedIn, on Facebook even. The people find me and they ask questions, and I'm super happy to help. By the way, on LinkedIn, that's my preferred method of communication for all this. Check out in the links below, you'll see my LinkedIn profile. All right, everybody, have a great day.